Well, it's great to see so many faces here. So, a quick intro for myself. So, Mehmet Sanliol, I'm at Evercore. I cover semiconductors, quantum computing, and engineering software. They all are areas that allow me to believe my physics degree is not gathering too much dust. But without further ado, over to our fantastic panel of investors. So, Nikhil, would you like to introduce yourself first?
I'm Nikhil Patel. Is that working? All right. I'm Nikhil Patel. I'm State Farm Ventures. I run emerging tech and enterprise tech for State Farm Ventures. Is that on? Yep. All right. How's that? All right, there we go. I'm Nikhil Patel. I'm part of the State Farm Ventures team. So State Farm Ventures is the State Farm Strategic CVC. I run emerging tech and enterprise tech for State Farm Ventures.
I'm Zeng. I'm a partner at Quantonation. We're the main early stage investor in quantum tech.
I'm Chloe. I'm one of the partners at a small fund called Quantacet. We're an early stage fund based out of Quebec, Canada that focuses 100% on quantum startups.
Eric Hall, a managing partner at Entrada Ventures, located here in Santa Barbara, California. A range of technologies, including semiconductor, photonics, but also some quantum technologies.
Fantastic. So we've got representation across geographies as well as with CVC. Nikhil, would you like to just give a little bit of color on how kind of CVC differentiates slightly from traditional financial venture?
Sure. So State Farm and many other CVCs are typically strategic in nature. So while we're looking at return on investment as part of our thesis, primarily we're looking at strategic fit within our corporate innovation system. So, for example, when I used to come to Q2B early days, people would ask me why somebody from State Farm was in the room. And typically, we're looking for opportunities to really bring in some of these emerging technologies to both augment and supplant our existing books of business. So this is really where strategic investment kind of differs a little bit from my institutional investment colleagues here on the stage.
Fantastic. So look, 2024 has been a breakthrough year across quantum technology. So we've seen logical qubits across multiple modalities. On the communication side, we've seen NIST release its first few quantum safe cryptographic algorithms. And on the sensing side, we've actually seen technology go into production, or into use, I should say, with the French Navy. So I'd love to get a view from everyone on kind of what is the timeline to enterprise adoption across technologies here, starting with you, Chloe.
All right. Thanks for bringing that up, because we do hear a lot about quantum computing, and I think it's important that we might talk about these other quantum technologies as well. From our perspective at Quantacet, since we're interested in all of these types of quantum technologies, we see that as a way to diversify our portfolio. Quantum being almost by definition, I would say, pretty risky from an investor perspective, it makes sense to dip our toes in different types of technology. So the way we see it, I would say cybersecurity is pretty much around the corner. The corporates finally are realizing, I feel, the urgency to find new solutions, whether that be QKD or PQC. Up to you if you define PQC as a quantum or quantum related, whatever. I'm not gonna argue on that. And then next, I would say, comes quantum sensing. Some would probably say that this is already technologies in market. That depends how much quantum, I would say, is in those sensors, but definitely the need is already there. Corporations need new sensors, more precise, more robust, more whatever you would like, which quantum can bring. There is still work to be done on the development side to meet the specifications that are needed, but the market is existing, as opposed to quantum computing, for example, where the market still needs to be developed. There is an appetite. These companies just need to meet the right specs, and then they can be in market. So that's also something that we, as investors, feel is interesting, because it gives a closer timeline. And then comes more of the quantum networking, as in entanglement distribution technologies, and quantum computing, which are a bit farther down the road, but which probably have larger markets. So that's as investors, that's what we need to balance. some applications that are closer to market, closer to revenues, but sometimes in smaller markets as opposed to other who are more long, short, and high risk, high reward opportunities.
Would anyone like to add any points to that?
I'd agree. Maybe I just add that sometimes at this event and in our community, we say like we have to do something that's quantum, and it has to be, there's some definition of it being quantum that's important. But at the end of the day, you want to make a great business, and people don't care about whether it's quantum physics. Now, they do care if it's a long-term differentiated advantage that can matter a lot, as opposed to a small tweak that happens in the near term. And when they hear quantum, often they're hearing the former. Like they're hearing, this is something new that someone else doesn't have that can give me a long-term advantage. But there are other ways to get there. And some of the companies that we like to invest in, particularly on the application side, have things inspired by quantum mechanics, but can build traction early on and start to turn on as quantum computers get better. So like a few examples, we have Qubit Pharmaceuticals is in our portfolio. They do quantum chemistry for drug discovery. Obviously that's going to get better with quantum computers, but they're running good algorithms now. Multiverse has been taking tensor network things and applying them to compactify neural networks. It's not running on a quantum computer, but that's got good traction now. And we've got a similar investment in a company called Quantum Signals that's doing the same with some quantitative finance stuff. So we shouldn't be too orthodox about saying let's not touch things that don't fit some definition of quantum, because the whole thing has to be an on-ramp to get enterprise adoption.
I think that's a good point in terms of ultimately what we're looking for is a business that can have a durable advantage, and quantum is potentially one, like quantum computing or some other quantum effect that you're using for your product is a way to get that advantage if you can harness that technology in the right way. But ultimately what we really want is to have a go-to-market, and as seed stage investors, we do have kind of the patience that your advantage could come in a further out time period. We can wait that long, but it should have some demonstrable, durable advantage that you'll have in the marketplace.
Fantastic. Thank you, Eric. So with all that said, 24 has actually been a pretty good year from a funding standpoint. If you include the grant that came in earlier this year, we're above $2 billion. And if you back the SPACs out of 21, that would actually be the kind of biggest year we've had to date. So given what we've just said about the various technologies, what are your viewpoints on how 25 is going to play out? Will, I'll start with you.
Yeah, I don't mean to take you to task, but I think that's an okay year. And maybe get a little bit of perspective, right? So how much did you say it was estimating for this year?
If you include the $620 million grant, then it's 2.1. If you back that out, it's more like 1.5, which is similar to last year.
Right, and like when Ilya, just him with no company, left OpenAI, like he raised that with no anything. And I think it's good to keep that in perspective, because what we're trying to do as an industry is a lot harder than buy a bunch of NVIDIA chips and put them in a data center and start training things. We actually ask a lot of ourselves, and at the macro level, if quantum computing and the quantum industry is going to be successful, that number is going to be much, much bigger. It's good news that it's not gotten a lot smaller, and other venture categories have done worse over the last few years. Deep tech in general has done pretty well at different stages, particularly at the early stage in terms of maintained venture capital funding globally. Quantum tech has done well too. And I think that's because people investing in quantum, especially at the early stage, and we try to do this, we're already thinking long term. So the macro environment affects us a little less. Now to look forward a little bit to 2025, there are some macro things that are helping. The political climate here is looking like it's getting, we can be more optimistic about exits and liquidity, which has been the big problem. So people need to exit from the large growth funds that they invested in the SPAC bubbles in 2021 and 2022, and get back some capital to reinvest in the new good ideas that you all have. And we see that starting to happen. So I'm optimistic for that reason.
And maybe a lead on from that is, one thing that has happened is the number of kind of companies that have been formed have been kind of slowly declining. I think the kind of steepest part of the curve was maybe about 3-4 years ago. So of late, that has started to slow. So what are your perspectives on why we're seeing less new company formation?
I can, sure. I mean, there were none, and then everyone who was a physicist was like, I can jump in. So you had like the first rushing batch, and so there was a big peak at the start when the gates opened up. Now we're getting a little more to steady state, but I think it's going to grow again. We're seeing, you know, the educational programs that have been put in place take years to actually produce graduates. You know, the master's programs have just gotten started. And so and secondly, people leaving existing quantum technology companies and starting new things. So I think it's more that the first wave was kind of high, and as it spread out globally, and maybe it'll dip a little, but I expect it to start going back up. Maybe other people can add as well.
I think what I would add is part of that is quantum specific, things that you mentioned. Part of that is also macroeconomics. So it's not only in quantum that we see this trend. It has been the same pretty much in every technology startup ecosystem. And that's because of the bubbles we had in a few years back, and then the macroeconomics conditions, how the market performed, and all of that. That's the first part. In terms of quantum specific, exactly like you said, I think that was the first wave. But now what we're seeing is that all of those companies out of the first wave have grown. They're raising money. They're now some of them are even unicorns, went public, and they're hiring. So all of the talent we're producing gets hired right out of the university. So they don't have this incentive, I think, as much as to start their own companies. That can also change. We've seen in big tech corporation layoffs in the past few months and years. I hope it doesn't happen in quantum as much as we've seen it in other fields, but these are waves that do happen in VC and in technology in general. And what this shows me is actually that, well, maybe for the first time, we're actually beginning to be a real industry that actually does see these waves.
And you certainly see that effect very geographically as well. So there's less big tech companies in Europe. The number of early stage quantum companies in Europe has continued to be pretty high. In the States, there's more of a pull from the existing incumbents. I don't think that'll last. It's just too much free market opportunity to do your own thing as an entrepreneur in this country.
I'll add one more kind of slightly contrarian point there from the standpoint that to what my colleagues mentioned, completely understand and agree there. One thing that I have noticed from an increased number of startups coming up is kind of further up the stack, right? So I've definitely seen more companies in what I would call sort of that middleware area or enablement, in especially in thinking about sort of these hybrid workflows where you can sit a quantum computer next to classical and HPC and the trillions of dollars of infrastructure that enterprise internationally have spent in kind of developing their technology to date. So I feel like to the point of some of these alumni coming out of these existing quantum companies have realized the difficulty or have imagined what it will take to drive the mainstream traction, and I've started to see sort of catalyzing around some of those technologies and workflow processes that will really be needed in order to drive that mainstream adoption.
Yeah, if I could make one last point here, I think the interesting next wave of companies is going to be a lot closer to that application layer. Folks who are trying to solve problems using the infrastructure that's being built. And to be honest, over the last year, all those kind of potential founder candidates were starting AI companies, right? Like, it's pretty easy, like you touch AI and then money comes. So I think that pendulum we're already starting to swing, and as the hardware gets there and as like we start to hit that inflection point, that's where we're going to see the next big wave of companies, I think.
So it's an excellent point. So could I just ask in follow-up to that, are there any parts of the stack or the value chain where you see there being gaps? Like whether it being kind of how we're stitching together classical and quantum, whether it being kind of on the networking side, whether it being like how do you orchestrate a data center? Like are there any parts of the stack that you feel like needs attention now that's not getting it? So if we have any young budding entrepreneurs sitting in the room, of which I'm sure we have many, they kind of should focus on that area.
Are there any gaps? Well, the whole industry is Swiss cheese. So I think like we're here talking about where are there not gaps? Because the whole thing's not working yet. In addition to the application stuff, one of the other gaps that I think, or opportunities that's emerged in the last few years is in the supply chain, the supply side of all this stuff. You know, 5, 6, 7 years ago, to do anything in quantum, you had to be totally full stack, and now there's an opportunity to attack different layers of it. We recently invested in the summer in a company called Q-Blocks that makes control electronics that I think a lot of people here use. So there's gaps in the foundry side of things, the quality control for scaling up, like all of the components that people have been buying from one small supplier in Japan, superconducting coax, or other kinds of stuff. Those things are going to need to industrialize. Some of them might not be venture scale, but there's certainly opportunities to look for in the, you know, what works now because you're making one test bed machine and won't work when you make a big fault tolerant one that you're selling lots of.
If I could add on this, I think on the angle of the supply chain, fabrication is still a problem. Like most companies are struggling just because their devices are not reproducible because of fabrication. So I feel there's a big need there to improve the supply chain fabrication side.
And is it, so putting my semiconductor hat on, is that kind of an issue of the foundries, or do you kind of already see that there's a specific equipment issue that, you know, where you can maybe see that there could be modifications made on the equipment side that would facilitate the fabrication? Or is it more in kind of the process?
Well, that's when you get into details, and then it depends on which quantum platform you're really looking at, whether it's superconducting or integrated photonics or spin qubits and so on. So I'm not going to go in details for each one of those. So I think part of the problem is the fabrication processes are not developed well enough to get the results that we hoped we had. And the other problem was that, and maybe the reason why they're not as developed as, for example, in the semiconductor industry, is that we don't have the volumes yet. So it's a bit of a chicken or egg problem, because you need volume to justify building a big fab and investing so much in fab processes. I don't exactly know how to address it, but if there's a smart entrepreneur in the room, maybe that's an interesting problem to address.
Okay, no, that's a very interesting perspective. Makes me slightly worried that we can't kind of find the people to fill our classical fabs here in the US, and now we're going to have a quantum problem, but we'll kick that one out. So on the theme of geopolitics, it continues to be front and center, I think everywhere, quite frankly, but none more so than in technology. It certainly impacts kind of my business day in, day out. And it's hard to open a paper without reading something regarding export controls. So this is a kind of multifaceted theme. So first off, I'd love to know from your perspectives, you know, this is a paradigm that's going to enable us to really take a step forward as humanity and solve intractable problems. How can governments best aid us towards that in terms of their policies and in terms of kind of capital deployment? Eric, would you like to kick us off?
Geopolitics, thanks. No, I mean, we do have a lot of semiconductor companies, a lot of photonics companies in our orbit, so we're living this every day, even outside of quantum. And, you know, on the world we're living in terms of the restrictions they have to deal with, it's increasing daily, and I think we can all agree that the game is going to get even more challenging. So I'm glad we're starting with maybe the positive side. I think there is a lot specifically, you know, the government has a mixed track record in capital deployment and advancing technologies, and there's kind of the whole range. I think in terms of like basic and applied technology, it's been quite successful, and I think that's still applicable to quantum. You see companies co-publishing with academics, kind of significant advances in this field, and you know, I think increasing the funding there will be good just from a basic bring up of science, but I think will actually help specifically the commercialization in the industry. Commercialization, deployment of capital by the government has a mixed challenge record, right? Like there's kind of various things. The guaranteed customer aspects I think have worked well, and at least in what we've seen in the past. You know, so we will buy a machine if you build it to this spec, and it allows you to kind of hit milestones and build something to that. kind of the direct subsidies of, we'll see in terms of like from the CHIPS Act, how that's going to work in the semiconductor industry, and we've got a very interesting test case there. It's got a little bit more of a checkered past a little bit more of a checkered record in the past, so I'm not totally convinced of that. I guess the final area that would be, and maybe it's selfish, but beneficial, and I think actually works well, is the, co-investment as, the various entities, they will make co-investments in startups, in any sort of growth equity too. They also make programs to help investors kind of support ideas where they see the advantage, and that again kind of democratizes the choice of the right technology, and I think ultimately probably makes better choices.
I love that. Love the points that you made. I want to add to that, but kind of go back to the last question a little bit more. So, I don't think it's a gap right now, but I see it more as an opportunity. But from the standpoint of education, I think that's a place where export controls can really be, like nullified, right? So, thinking about governments making investments into, specific parts of the education stack in their home countries, and really driving, sort of initiatives towards these technologies, these global initiatives that they can start to then create, opportunities to communicate at conferences like these, where you can really trade and discuss ideas without the sort of overhead of export control. Kind of going back to this idea of education as an opportunity, then, one of the areas where I think needs immediate, sort of intervention is really around sort of educating in the industry around quantum and related technologies. So, for example, we all saw the Willow announcement recently, and there is a lot of hype around it. And don't get me wrong, I think it's an amazing accomplishment. But at the same time, the way that it's being discussed in the areas outside of the paper, it's very grandiose. And I think part of what that does then is, when you talk to the executives and you talk to the people with the purse strings, you're expecting the moon, and you're getting cheese. And so I think part of what needs to be done from that standpoint, and I look at it also as, how are you going to train the next generation of engineers and scientists and related folks to drive these advancements forward in the future? I think part of what you have to do now is start those educational programs to make and put emphasis on these technologies, including quantum, that will drive the future.
I agree with that very much. I want to highlight something Eric said. There is a program that we're not doing in this country that we should be doing, and I think would have the biggest impact on quantum computing. And you all are in the industry. The administration just changed. People are going to be asking you, what should we do? Here's what I think we should do, and I think you should tell them. I think we should have a challenge program where the government commits to buy quantum computers at specs between now and utility scale, and including utility scale. Not just one, but several, and not just the big one that already works, but ones along the way. And this should be a multi-billion funded program. This works very well because the government only pays for things that already work, as opposed to trying to guess what's going to work in advance, which deals with a lot of the political issues and subsidy issues that don't work well. I think if we did that, it would catalyze a huge amount of private investment because it helps cross the chasm. And then secondly, what does the government do with the machines that it buys? Well, that's what goes into test beds and are made relatively freely available for application development and use by academics, end users, and all sorts of folks. We're not doing it yet. I think we should. If you disagree, come find me. If you agree, come find me. But I think that's what we need to do. And by the way, other countries can do it. And if we don't, they will.
So that sounds like great advice in terms of making sure that there's more on offer kind of coming in from the government side. One thing I'm actually often asked by early stage companies is, how should an early stage company think about its customers and where they spend their time with regards to government, DoD type business relative to chasing commercial business, which may be a bit trickier, and would love your take on where they should spend their time and how you all as investors actually value the various revenue and booking streams, so to speak. Who'd like to take this one?
My answer is very simple to that. We always encourage our portfolio companies to go after non-dilutive funding at the condition that it's on the roadmap. So it's as simple as that. If the project you're proposing through this grant is aligned with what you would do anyway to get where you want to be, what you've pitched your investors, whatever has to be done, go for it. If it's tangential and it forces you to put your time on something else that you wouldn't do otherwise, then don't do it.
Yeah, I'll add to that. I also run a research lab and a venture studio affiliated with Stanford, and done quite a bit of startup entrepreneurship myself. But kind of the generalized guidance that I tend to give to my spin-outs is this. So kind of a three-phased approach. So phase one, to your point, non-dilutive funding as much as possible allows you to be very introspective and kind of develop the technology to the point that it becomes robust and you understand it well. Phase two, strategics, POCs, engagements, as many of these as possible. Specifically, the reason why this kind of allows you to really look for the different use cases, and it could be in a completely different area that you weren't thinking about before when you initially created the technology, and that in itself is a important part of that product market fit, because the more of these conversations you can have and the more of those difficult decisions you face kind of gives you the resiliency, but also the flexibility to really drive forward. Finally, phase three is where you come to us, where we can really help you ramp up and open that network to connect you to the right folks and really drive up that scale, right? So I think from that standpoint, there really is no this or that. It's always a combined approach.
Yeah, I think the thing that's often overlooked when you think about the government is that the government's not looking to fully fund their version of something all the way. They would really love to take something that's commercialized and tweak it for their effort, right? That's a much lower cost overall, and they know that there's this big base of technology they can work on. So we always encourage folks to really go and understand the government problems if they're thinking like on the non-dilutive, or they're looking at actual commercial applications, and understand, have those conversations with those stakeholders and understand how far away they are from commercial, because it usually ends up being a lot closer, and so you can get it really aligned with your commercial roadmap. In any sort of kind of variation for the government is much more manageable.
Got it. All great advice. So finally, on the geopolitical theme, I'm fairly well versed on the semiconductor side with regards to export controls, but not so much on the quantum side. So I'd love for you to be able to advise all of the great folks in the audience as to what they should know about export controls and how you as investors factor it into your calculus. Will, would you like to kick us off?
Yeah, so it's clearly a developing situation is the first thing to know, and it's changing a lot. It's changed in the last couple months. The world's splitting into, I suppose, two pieces. There's the US and the West, and then China and Russia, and there's a few countries that sort of haven't made their pick yet. My advice for early stage companies in this space, and this applies not just because of export controls, is you really need to think globally from the beginning. And part of that's because this is a new market. It's not that big, so it makes sense as a venture, for some of the things, it makes sense as a venture scale market only when you take into account international customers, international markets. And so you, from day one, should be thinking about, how do I get to customers in other countries? How do I develop there to have access to non-dilutive funding opportunities? And it's actually hard to think of, most of the quantum companies I know are in multiple countries to some degree. So that's advice that we give pretty early on. It just gives flexibility.
one thing I can add is also from the beginning, you also have to think about who do you want your money to come from. We've seen many companies get an early check from, for example, a Chinese investor, and that can be a complete roadblock for in the future fundraising. So those are things that you have to think about.
Yeah, I've certainly seen that play out. So that's great advice. So it wouldn't be 2024 if we didn't talk about AI. I think there has been a lot of excitement about the confluence of AI and quantum computing and broader quantum technologies. So, I'd love to get your take on, for everyone in the audience, how should they be thinking about this theme and kind of working it through their stories? And I'll just give one comment, which is that this is an exceptionally kind of honest crowd and audience. And from a fundraising standpoint, there is something to be said for pursuing the dream and kind of talking about the possibilities. But would really love your take on this. Chloe, would you like to start?
Sure, that's a very good question. I'll start by saying that at Quantacet, it is partially our role to talk to other investors most of the time, or non-quantum specific investors who are interested in quantum. And we get that question all the time because there's so much hype on AI and there's so much hype on quantum. So in their mind, 1 + 1 = 2, and that's double hype for quantum AI or QML, whatever you call it. So I would say it depends. So advice for startups, it depends which investor you're talking to. So it can be very sexy for these kind of investors to go out with the quantum AI story. If you come to investors like us, I'm not going to talk for the other ones here, but more quantum savvy investor, I would say we recognize a bit more the challenges and what we can really expect from from quantum AI, quantum machine learning, and I mean, you've probably heard the talk this morning from Scott Harrison. We don't know if there's anything really like any acceleration power out of these technologies. So it is interesting. We definitely keep an eye on it, but we won't put all of our eggs in that basket. However, very much interested, you mentioned that earlier, Will, in companies that leverage both technologies, maybe as an alternative, or companies that use an AI engine today and are hoping to swap it for a quantum engine in the future. If quantum machine learning actually never delivers, it's not such a bad deal because they already have something working today. They are onboarding customers. If it does work in the future, then it's a double success, and that's even better. And they've already it's actually a good thing that they also started with classical technologies because it allows them to onboard customers earlier and then get that early traction.
So just on this topic of kind of moving into applications, I'd love your views, just given that you speak to many folks in the community, of where do you see the killer applications and where do you see how do you see the timelines? How do you see this unfurling? I've seen different people kind of talk about different use cases, kind of being first. So would love your views, maybe starting with Nikhil, and then we'll kind of work our way back.
Sure, thanks. So I think Chloe may mention it earlier, but PQC I think is the first toe in the water for most enterprise and frankly like implementation to begin with. But I think in my opinion, the two killer apps that I particularly am looking forward to, and I think will make the biggest splash, and it's kind of connected back to the AI question here. So first, QML. I think at the very least, the sustainability aspect of it, I mean, energy, processing power, consumption, like it's just untenable as we think about, where AI is going now. I mean, how many nuclear power plants do we need to spin up before we realize that we need to change our tact? So I think QML really brings together an interesting confluence of power, of resources, of sort of potential as we think about just the scale of problems that we can potentially throw at it. And if not for anything else, if we don't get anything novel out of it, I think to Chloe's point, we can get some resource and utility in terms of trying to replace some of the power hungry systems that we have now. I think in addition to that, and maybe this is a follow on, based on that, because I think it's built on top of QML, but I think simulation is an area that is huge, at least in a lot of sort of industrial applications. Insurance isn't so much industrial, but we have a lot of the same problems, and I think that therein lies the beauty that a lot of the people that we talk to in the quantum space have these list of case studies that they've worked on, and the funny thing is that most problems are probably just like analogous to some of these problems that we've already solved: optimization, QML, simulation, others. And so being able to tap into that, A, kind of gives you a faster road to market, and B, gives you the ability to kind of ask what if, and do a lot of sort of brainstorming based on that.
Well,
it's kind of funny being asked in a panel in front of this audience, like, what are we going to do with quantum? I feel like that's like what everybody's been talking about the whole time. Though I don't disagree with everything you said. So maybe rather than answer the question directly, I'll just give one example of something that isn't talked about as much, that might come to a little advantage, which are the outputs of doing designs and quantum simulation with quantum computers. So quantum simulation looks like it'll come soonish. But rather than sell quantum simulation, you could sell what you design. And an example company in our portfolio is a company called Pionic. They're early stage, and we call them a quantum material company. The founder had been researching high temperature superconductors for many years, an academic in France, and found something else. And the only way to understand this material is it's a strongly correlated quantum material. Designing more things like this is what we'll be able to do with quantum computers. But they're building it's a supercapacitor. They're building a thin film battery technology on top of this material, and growing it out that way. And so those kinds of companies and those kinds of opportunities are ones that we haven't seen as much of, but I think we're going to see more, and they're likely to show advantages sooner.
I'm going to go somewhere else. I would say that I see a lot of attention shifting a little bit from quantum computing, which was attracting most of the attention, towards sensing and communications, cybersecurity, which I would define as a less sexy applications. So I guess that's my point. I'm interested in things that are not as sexy, which also is, for example, bringing quantum to more traditional, industries. It can make quantum computing as well. So thinking of traditional industries like natural resources, manufacturing, I think there are big gains to be made in those industries. Maybe they're not as sexy as pharma or finance that we keep hearing about, but it also means to me that it's a bit less competitive as a space, and I think there are interesting opportunities there.
Yeah, I'm gonna take that from exactly where you left it off. I think one of the really interesting thing is when we were at Supercompute this year, and there was a big quantum presence there, and you kind of see that the folks who are kind of used to making large calculations are starting to notice, right? And these are folks, domain experts. They have interesting problems, and they know clever way to solve their problems, and they're going to start seeing a new tool to do it.
So maybe one quick follow-up on that is, I've seen some application vendors more maybe on the chemistry side emerge, kind of verticalizing, so to speak. Do you see opportunity for kind of other verticals to emerge, or maybe where would you like to see someone verticalize?
Materials.
All right, perfect. Well,
Energy, I think, as well.
Yeah, that's a big one. Especially with the demands that are coming. You're turning on nuclear power plants. There's opportunity to come up with other scalable energy solutions. There's one thing we haven't talked about yet, maybe that I feel a little bit remiss in not mentioning, which is just all the stuff that's going on in error correction and how that's going to shift things. We had a lot of great results of obviously the Google one, but there were tons of roadmaps presented here that are really exciting. You've got bosonic stuff from Nord, 1 million times improvement on the number of sources from Candela. Like there's like lots of new architecture ideas. And the roadmaps are going to get more concrete. And there are going to be new startups, and I believe there are going to be new quantum computing startups whose first milestones are logical qubits at the earlier stage. We're not there yet, but that's going to shift the practicality of this. Is going to shift the landscape a lot, and I think that's something in the next 4 years that I'm looking out for.
And I look forward to that because hopefully that's going to unlock the kind of one thing we also haven't spoken about, some of the growth stage funds coming in. And hopefully that's going to be an important part of how we can bring them in to fund the next stage of development. So we're bang on time. So thank you, everyone. Thank you to our panelists, first and foremost, but also thank you to the audience here.